In this lesson, we're going to take a high-level overview of the things you need to consider around authentication and authorization inside of AWS. First thing to realize is that you're now dealing with cloud layer security and non-cloud layer security. The cloud layer security involves access to the AWS web console, which is going to have a username and password, individual API calls, which are going to require access and secret keys, and you can control access to any of these with MFA or multi-factor authentication, which we'll talk about in a bit. On the non-cloud side, you still have your application, your operating system, and the underlying server logins. Remember that you're going to actually be building servers on top of EC2, and you're going to be putting applications on top of those. So the non-cloud applies whether you're in the cloud or not. Let's first look at the cloud layer security that's involved. This is security to AWS products. You have the access to the AWS web console, where you can control a limited number of the products. Access to this web console is controlled with the username and password, which you see here. Remember, we can have master accounts or IAM credentials. The master accounts are literally the keys to the kingdom. This is the account that you created when you first signed up with AWS. It has access to everything. You want to be sure that you record these keys on a USB and lock them in a safe somewhere so that they run no danger of being lost. On the IAM credential side, you can have up to 5,000 accounts pre-created, or you can create them on the fly. We discussed this more in the IAM decks. On the AWS API access, you actually access API calls via signing them with your access and secret keys, which you see here. Again, you have master credentials for the entire account, and you can create IAM credentials with the same 5,000 or unlimited on-the-fly limitations. We can lock down access to individual API calls with what's called MFA or multi-factor authentication. These are essentially little key fobs that you pass out to individuals in your organization. The key fob has a rotating number on it that requires you punch the number in when you access the code. Amazon also provides apps for iPhone and Android, and you can download virtual MFA appliances for free. The key fobs themselves are only $13. Again, when we talk about master account credentials, consider these as root-level credentials to your entire account. They allow all operations on all services. Make sure you don't lose them. A best practice is to instead limit access or create IAM master accounts and use those instead. On the cloud layer security, we can also use IAM accounts. These give you more granular access to resources and API calls. Each user here is going to be given their own set of credentials. They'll have their own access keys, their own passwords, and so on and so forth. You can put these users into groups. Here you can see that we've created a user named John Smith who has his own access keys and passwords, and we've put him in the DB admins group, essentially giving him access to all the database-related operations. These credentials can auto-expire, which are great for federation, subcontractors, end-user access to S3 buckets, and so on. We discuss all this in greater detail in the IAM decks. Let's look at cloud layer security regarding logins. Remember, there's two kinds of accounts we can have: a master account login, which we see the login for here, and an IAM account login, and we see the login for that here. Notice that the URLs for these are going to be completely different. The master account login is going to be console.aws.amazon.com. The IAM account login is going to be given to you at creation time. It's going to be an ugly long URL, something like 29627.something.amazon.com, but it can be aliased, so you can do stuff like make your login URL be infiniteskills.aws.amazon.com. Please note the differences. Be very careful when you're logging in with the master account, as this would be akin to logging into the root account in a Linux server. On the non-cloud layer security, we still have the same things that we've always had, and you should follow the same best practices you've always done regarding your application, your operating system, and the server access. First, let's look at application. One of the most important paradigms in security is the rule of least access. Make sure that only folks who need access do have access to the application. You could, for example, on an internal application, lock it down to a corporate IP address range. Make sure that the username and passwords are stored in the app database. This is application-level security we're talking about. Another best practice is to port scan your app with a product like Nessus. And if you have a very complex app that uses a lot of independent packages, it's a very good practice to use something like Sonatype CLM to proactively monitor and update these application components. One of the first things you're going to want to do is keep your packages patched. Sony Corporation, for example, ended up on the front page of the New York Times when they simply forgot to update their web server and it was running with 3 or 4-year-old software and it got hacked. Chef, Puppet, or CF Engine are tools that can help greatly with this. These tools automate the process of package updates. Rather than going into 100 servers manually, these packages can log in for you and take care of package updates and so forth. Leveraging groups to lock user access. Using intrusion detection systems such as Snort, Tripwire, and OCSec so that if you are hacked, you at least have a record of it and you can keep folks from doing bad things. Rotating your keys and passwords regularly are something that few organizations do, but everybody should be doing. When we talk about server access security, again, we're going to want to obey the rule of least privilege. Try to launch EC2 instances into IAM roles. This keeps you from copying credentials all over the place, and it centralizes and codifies the access to your backend AWS resources. Something I really like to do is create an SSHers group and use that to control access. I make sure that only users which are in this group have access to the SSH daemon. Another best practice is to use something like a bastion host, where you have backend systems which cannot directly be accessed by the outside world. Here you see that we're using this bastion host, and only this machine has access from the internet. These internal machines then allow access only from the bastion host and have no internet access directly. Some of the other best practices to look at. Try to control AWS service access via IAM. Try to secure all non-cloud layers individually, and maybe even have concentric layers of security in your application, operating system, and server. Again, trying to follow all non-cloud best practices, such as rotating credentials, providing needs-based only access, and provisioning, deprovisioning users as they come and go from your organization. This has been Introduction to Authentication and Authorization.